Well, good morning, good afternoon. Hello, everyone. Welcome to today's webinar titled Basics Every Machine Learning Practitioner Should Know in 2021. My name is Michelle. I'm here to produce the session. Before we jump into our introductions, I want to give a quick tour of how to navigate the virtual platform. So as you joined, you probably noticed that your microphones are disabled. So if you have any questions, comments, they are more than welcome. They are invited in the chat icon. If you take your mouse and hover anywhere inside this platform, you'll see a toolbar at the bottom of your screen. One of those icons is labeled chat. Click on that to find the chat window and post your questions throughout the session. We are recording the session and we'll email a copy out to everyone who registered by the end of the week. Our presenter today is Chris Skrinak. Chris is the Global Machine Learning Technical Lead for the Amazon Partner Network, commonly referred to as the APN. He co-founded the Machine Learning Group for the APN in 2017. Chris started his career as a quantitative strategist at Goldman Sachs, developed a predictive maintenance apps as an AI engineer at ATT, and prior to Amazon was computer vision architect at GoPro. It's a very cool portfolio. He founded and sold 2 Silicon Valley startups in finance and networking monitoring, ClearStation and SiteRock. As a technical lead for horizontal support of AI ML, he's the first line of support for AWS partners looking to develop or expand their use of technologies across all markets, including finance, healthcare and life sciences, public services, telecommunications, and e-commerce. All right, we are in for an excellent webinar today. And Chris, the floor is all yours.
All right, well, thank you very much for that introduction. I'm very happy to be here today. I would like to start off by just saying we're at a very special moment in machine learning where an enormous amount of highly, important and breakthrough code has matured. And because of that, there are certain things now that really every practitioner needs to know. It doesn't matter sort of what your role is, whether you're a developer, a data scientist, whether you do DevOps. And if you're just getting started in the field, then this is what I consider sort of my best starting point for folks who really want to get into ML. First of all, there's good reason to panic. When you just take a look at the services that are available on AWS, well, the way we describe it is with this 3-tier stack. And on the top level, we have AI services. These are services like every other service on AWS, like our storage S3 or our instances EC2. What I mean by that is they're accessible through the graphic user interface and the console. They're available through your command line interface, just using Bash or a Windows panel. And they're also available in a higher and lower level SDK. So when it comes to that top level of the stack, I'm really going to be focusing quite a bit on that today, because at this point, no one would think you were a storage expert if you knew how to get a file out of deep storage, or Glacier as we call it, on S3. You do it through the user interface, you'd make a simple call from the CLI, no big deal, right? And the analogy I'm trying to make here is that that's exactly where we are with machine learning today when it comes to most of this 3-layer stack. The exception to that rule is the center. Amazon SageMaker is the seminal end-to-end machine learning bespoke model development IDE. And it is a breakthrough product. It has so many subcomponents that any data scientist who really wants to get into creating high performance models that not just run in the cloud, but might run on PC or Mac, on Android or iOS. I mean, it is the place where you make these models. I'm not going to cover much of that today because, frankly, there's a lot of material out there and it's pretty advanced. And sometimes you need a couple of weeks or months of training to really begin to understand that. But I think we're going to be able to create a bridge for that today, too. On the bottom layer of that stack, three-layer stack, we have our infrastructure. Now, we include in that infrastructure some of the deep learning frameworks like TensorFlow, PyTorch, and Apache MXNet. We make it very easy to use those frameworks for data scientists by putting them in images that you can load up on an EC2, or of course load up with various configurations in SageMaker itself. We also have the most robust set of GPU instances out there. We actually make our own chips now that are specifically designed for machine learning training and inference. Inference is when that model goes into production. We also have something called elastic inference. So if you just have an EC2 instance, one of the $5 an hour ones, like really, or 5 cent, I should say, an hour ones, really cheap instance, you can attach a GPU to it just by clicking a checkbox in the GUI. We call that elastic inference. And we also have field programmable gate arrays. That's a lot, but wait, there's more. Machine learning is really just software development, and it has found its way into almost every aspect of the services at AWS. Importantly, our relational database systems like Aurora, Athena, Redshift, and Neptune, and some of our relational database partners, such as Snowflake, can easily now automatically create models with SQL. Then there's Glue Data Brew. This is a breakthrough data prep tool that has a parallel in SageMaker called Data Wrangler. In our business intelligence suite, QuickSight, we have something called ML Insights, which not only can understand language, and you can do ad hoc natural language queries to create reports or charts, but we also can generate language based off of the data that you're using. So it's a data generation tool as well. And I mentioned Trainium and Inferentia, our custom chips. But breathe, if that got you a little bit excited, it's going to be okay. In fact, there are evergreen patterns and principles that I'm going to walk through today. And once you notice them, you'll see them throughout the stack. So it really makes everything that I just mentioned a lot more accessible. So what are we going to learn? First of all, I'm going to tell you machine learning's dark secret. I'm going to give you some information on how to prioritize requests for machine learning development. What are the roles in the life cycle? What is the basic terminology? When I found with executives, decision makers, sometimes all they need to know is to understand the words that are being used in a field, and they're 50% there. What's possible without prior machine learning training? And that's what we're going to focus on quite a bit. What kind of models can you create with little or no code? How does DevOps work with machine learning? What is AutoML? What are solutions that are ready out of the box? And when do you actually need a specialist? So let's break this down. You may already know much more than you think. Here it comes. Machine learning's dark secret is it's not about the algorithms. Machine learning is really simple when you look at it from this perspective. Data writes code. Now, I say that, and it's very simplistic, but there's a lot of truth here. When you're actually creating a machine learning model, what you're doing is you're taking data and you're matching it to an algorithm. Now, let's talk about those algorithms for a moment. There's a bunch of kits out there, Python mostly, but also R, even in Java now, where all these algorithms are already there, like grep and sort, say, in Unix. You wouldn't go through the effort of rewriting those utilities. You shouldn't do the same in machine learning. It is so robust now. It is so mature and so rich that really a smaller and smaller fraction of machine learning tasks actually require writing an algorithm from scratch. But without this principle, this notion that data is going to write the code for you, it's really easy to get lost. So if you start with this basic principle, then the very next step is to say, well, what really makes machine learning code different from, say, Java, C++, or things like that? And that is that every output of a machine learning model is a prediction. And because that's true, you're always going to come up with some accuracy measurement for its use. It could be high, it could be in the high 90s, 95%, 97%. I have seen some models go into production with as low as 70 and 80%. It really depends on the use case, right? If you're trying to detect whether a tumor is cancerous or not, you might want to have really high 90s. If you're trying to select the next product that someone might want on your website, you might go for a lower figure. But basically, all code written with machine learning is going to be predictive in nature. In fact, I often say that AI and machine learning itself are misnomers. This whole field should really just be called prediction, but it's a lot sexier. I also want to discriminate very carefully between analytics and machine learning. Now, analytics, predictive analytics, or the phrase that we use here, augmented analytics, has been around for quite some time. And when you break this down, a lot of this is just based on a lot of simple statistical methods, with the possible exception of deep learning, which has, the neural network aspect to it. But we're going to talk about machine learning. And the way I describe this difference, once again, half joking, is that analytics creates reports, machine learning creates endpoints. So we're going to write code with machine learning. And if you get lost as I go through this, just remember, data writes a code. Data is absolutely paramount. And as you go through the life cycle of a machine learning model, how it's developed, you'll see frequently people say 80% of their time is spent wrangling the data. Well, that is not wasted time, because you're a data scientist, perhaps, or a programmer that's using some of these tools for the very first time. You may not be the domain expert. The domain expert knows a lot about that data. You might not. So that 50 to 70% of your time that's spent wrangling the code and getting it ready to fit to an algorithm is not wasted time. It's an absolutely essential part of the process. So let's talk about that process. We start by collecting training data. One of the things I often say about machine learning models is every machine learning model is obsolete on production. So how could that be true? It's true because that model was written with historical data. Once you put it into production, you have fresh data, you need to monitor it. I'll talk about that in a minute, but that's where we get into the DevOps and MLOps aspect of this. But data is absolutely key. Then you choose an algorithm. Here's another dirty little secret. There's basically only three things you can do with machine learning. That is predict a number, predict a class, or discover a class. Sounds really simple. That is regression, classification, and clustering, respectively. Really, three things do almost 90% of machine learning and solve most business problems with machine learning. So when you go to choose your algorithm, that's one of the first questions you ask. Am I predicting a number? Am I trying to predict a class like cat, dog, for example, pedestrian, things like this in computer vision? Customer that will come back, customer that won't come back. These are all classes. Then you have to set up and manage that environment, train and tune your model, deploy that model into production, and then you need to scale and manage it in a production environment. So when you take a look at that big picture, the actual code that creates the algorithm is a really small part of the process. It is an important part of the process. It's kind of like saying the heart is just one organ in the body. But the reality is, this is really the big picture of how machine learning code goes into production. And who puts it in production? Well, there's a couple of teams. You definitely have data scientists and data engineers. And frequently in large companies, these are two independent groups. In a startup, it might be one person doing everything you see here. But more frequently, data engineers are folks who've been working with relational or graph databases for decades. That's their area of expertise. And they need to communicate with the data scientists. Where is this data? How should it be formatted? How do you need it formatted for your model? If it's tabular data, there may be peculiarities. So for example, all machine learning models need numbers to work with. So if you have a lot of words, you have to vectorize those words. So that's a data prep concept. Now you put that model into production and you're going to be working with QA. We'll be working with machine learning engineers and other developers and the whole set of DevOps personnel. What's critical here is that each of these roles understands the goal of each other so that they can better communicate. I won't go through this in detail, and of course we're being recorded here, but basically your data scientist, data engineer, and DevOps have very narrow responsibilities in this process. Once again, if you're a startup, you have to do it all. So let's talk about the terminology. Well, like I said, this is 50% of it beginning right now. I mentioned regression, classification, and clustering as the principal goals of almost every machine learning model. And I said it was about 90%. So what's in that last 10%? That is going to be a number of things, but most importantly, reinforcement learning. Reinforcement learning is when you actually learn through trial and error. Regression and classification are frequently called supervised learning. Clustering is frequently called unsupervised learning because when you're looking at data and you don't know how many classes are in there, you have to discover that, and you do it through trial and error. Deep learning simply means that you're employing a neural network, which is simply a matrix of nodes, of numbers that are automatically generated for you through iteration when you're making a deep learning model. You'll often hear structured and unstructured data. Structured data, just think of it as a spreadsheet, rows returned by a relational database, and unstructured data is everything else. But this is also principally key. Thanks to the advancements in deep learning, almost everything digital now you can consider data. That's usually photographs and videos and audio, but anything, any sensor data coming out of an IoT device, what temperature is it? Is this machine vibrating, etc. This is basically going to be unstructured or sometimes time series data in those last two instances. People use the word model a lot. At AWS, we're very careful about discriminating between a model that's in your code, that's an algorithm that's fit to your data to produce a model, and model artifacts. Model artifacts you can think of as compiled code. It's the model that was actually generated by training your data, and it's the model artifacts that go into production. So we make a very careful to distinguish how those words are used. Training is when you, as I mentioned, fit that data to an algorithm. That is the principal job of a data scientist or a developer who's using some of these higher end tools. Inference is the prediction that's returned when you send fresh data to that model in production. That's actually how you're using the model in production. And by the way, up to about 2 or 3 years ago, most of the cost was associated with training because GPU instances were very expensive. Now, thanks to AWS and cloud models such as we have, really the biggest expense is now in inference. And that's good. That means you created a model, you put it in production, hopefully you're making money with that model, and so it's paying for itself. But now a lot more attention and cost reduction is on that model in production. Okay, Chris, go ahead, I'm sorry.
Just before you move on, I think there's a question that might actually fit those definitions really well. I don't know if you can see the one. It's asking, how much labeled data do you need to create a class identifier? Would a couple hundred do it? And then they ask about reface, seems to only need a few. I think it's the difference between training a model and applying the model.
Mm-hmm. Right. Well, so the short answer to that is it depends on the use case. And frequently you don't have a lot of training data to begin with. On AWS, we have a lot of tools in SageMaker. One of them is augmented AI. What augmented AI does is you build a model with whatever data you have. It could be 100 rows. You put it in production, and then when the results come in at a number lower than is production worthy, say 69%, that data gets set out to a separate file for human labeling. So that's really what I recommend for most folks who don't have a lot of data to start with. And we're moving into this phase now in machine learning where kind of all the low-hanging fruit's been taken, right? Or it's covered by the services that I'm going to go through. So, when you don't have a lot of data, augmented AI, human in the loop labeling, and iterating through model after model after model, you could quickly get up to model 15, 20, and 30 using this strategy that I just described. But you get a very rich rich, highly accurate training set very, very quickly. But it requires engagement, right, from all those stakeholders that I mentioned earlier. All right. It's important to know the names of the tools of the trade. These are the basic tools, the basic terms you have to know in this field. Number one, Anaconda. Python is the lingua franca of ML, and most people are using Anaconda. Anaconda is open source. It can run in the cloud on a machine. It can run on a little Raspberry Pi if you want, but it makes it real easy to change environments to do ad hoc work. And if you hear Anaconda, they're really referring to the Python instance of Anaconda. Jupyter Lab is the principal IDE for developing machine learning models or orchestrating the services that will build that model. So Jupyter Lab is an essential part of SageMaker. AWS is an important contributor to that open source project. Now, I put a little crown by scikit-learn because scikit-learn is so basic. A lot of people talk about super sexy things in TensorFlow or PyTorch, etc. Scikit-learn does all the basics, and it's also a great educational tool. I always recommend folks that I work with know scikit-learn cold before they get into any kind of deep learning. Pandas is just basically how we do tabular data manipulation, and OpenCV, like scikit-learn, now does a lot of things that were formerly only possible with deep learning. So if you're doing computer vision, OpenCV is an important tool. Deep learning frameworks, I mentioned them before, TensorFlow, PyTorch, and MXNet. These are the big three. I'm a bit of a PyTorch bigot. I'll just put my bias out there. I use PyTorch pretty extensively. And I mentioned the deep learning containers that we have, or AMI, which is Amazon Machine Image, which actually are managed products at AWS. We could coordinate all of those tools you see above into something you could just stand up on an EC2 instance and get right to work if you use the deep learning AMI, and it's free. The instances aren't free, and here are the categories for the instances at AWS. The P class at the end there are the ones with the really high-powered NVIDIA GPUs. Last but not least is the Neuron SDK. Neuron SDK does a number of things, including dramatically increases efficiency of your production models before you put them into production, but they're required if you're going to use our custom CPUs and GPUs. All right, so popping to the next set here, it's really easy for any programmer, even people who just know Bash, the Bash shell, to put machine learnings into production. I'm not kidding. Whether it's vision, chatbots, et cetera. And it's because of the growth and the maturity of these high-level AI services. And I'm going to walk through some of the key ones right now. So first of all, language translation is essential. It's common outside of the US for people to speak multiple languages. Of course, we're English-centric in North America, and just about everyone speaks English around the world. However, when you want to highly personalize your experience for your customers, it's important to translate between not only languages, but dialects, and that's what Translate does. Transcribe will take speech from audio and video files and output it in a JSON machine readable format. Next is Textract. Textract uses computer vision to look at a page of text the same way we do. So when we look at a piece of paper, we generally will take a look at it and say, okay, there's a header, there's a footer. Oops, I guess there we go. A header, a footer, there's something that looks like a table, there's a photograph in here. Textract goes through and does highly accurate semantic segmentation is what it's called in computer vision, and then applies appropriate algorithms to each of those components to create machine readable code. We can also do branded text to speech, and we have two great examples. And I'll give you just, when I do the demo, I'll do a quick demo of what that sounds like. We have the kernel for Kentucky Fried Chicken and an Australian bank, NAB. So next up is personalize. Obviously, the Amazon Recommend system is very famous, and we've taken all the exact same tools that we use at Amazon with the billions of SKUs that we have, and made all of those tools accessible to you through this high-level API called Personalize. Time series forecasting is an essential part of prediction. We have methods within forecast where all you have to do is provide data. actually no programming whatsoever, and create highly accurate models that used to take months to put together. We have a number of algorithms that we apply to that, such as Profit, ARIMA, and even deep learning autoregressors. So it's you basically, it's a hands-off service. You just give it data. Next is fraud detector. It has the exact same model. It identifies potentially fraudulent online activities such as payment fraud, fake accounts, etc. Now, the reason I grouped these three together is that they all have that exact same model. All you need is data. You create a data set, you can do it all in the GUI, you push a button, and out comes an actually high accuracy machine learning model. It's the same for all three of these. What's a little bit different are these two right here. Kendra uses intelligent search with natural language to create, highly effective search mechanisms. And what it does is it actually enables you to just take your Salesforce, your SharePoint, PDFs, FAQs, just put them in a data set. We will search it for you. We do everything. Sometimes we call this the fourth layer of AWS because it uses all of those elements that I previously described to make a very effective search experience for your website. Then last but not least here is Contact Center and our introductions now by integrating all of those media tools to create excellent customer support. Just a little bit in SageMaker. If you do want to dive in there, we have a product called Autopilot where you simply provide data. And then I have always advocated creating a web app to demo my models. We have something called Amplify on AWS that makes it really easy to create React models, even React Native that can run on phones. The executives, the customers that you're creating code for really don't care about data science statistics like root mean square area or area under curve or something like that. They want to see the model in production. Amplify makes it easy to call any of the high-level service that I mentioned. And I have a GitHub repo there that I call nuts because it's nuts that people don't use it. It uses React to just do this very simply. I don't have a lot of time for a demo here, but I do want to point out just very quickly how easy this is. I have a video that came out of reInvent 2 years ago. It's this gentleman talking about EKS with Kubeflow, and I really liked it. So I used a tool, a plugin for Chrome to download that, and I went to transcribe, and I created a transcription job. All I had to do there was give it my S3 location and push play, and it basically transcribed that entire thing. I would also like to just very quickly do one or two things. I have, I'm just going to cat out in a terminal here, which I made kind of big, the lyrics to a song by a band I like, King Crimson, and here it is right here. And just using the CLI here using Poly, I can actually output that and play it. Now I'm obviously copying and pasting here, but you can see I'm using the AWS CLI.
Road is cracking at the seams upon the instruments of death. The sunlight brightly gleams when every man is torn apart with nightmares and with dreams. Will no one lay the laurel wreath when silence drowns the screams?
There we go. So let me stop this player now. There we go. All right, cool. So the point here is, this is how you call any of those AI services from the command line. I mentioned, there's 4 ways to do this. This is 9 times out of 10 in early stages. I will pick one of these AI services, in this case, Poly. Poly has some arguments here to synthesize speech. And if you're curious about what all the options are there, you just basically do that and say help. So you can imagine here now going through every one of those high-level services and getting whatever you want, whether that is a photograph. What are the objects in the photograph, the activity, who are the personalities? You can detect up to 20 million faces with recognition. And recognition and comprehend both have something called custom labels, where once again, zero programming, you just provide custom labels for the data that you're giving it, and we create a highly accurate model. I want to very briefly, I'm a solutions architect, so I love seeing architectures, show you an architecture for this kind of thing in production can be this simple. And I have, something here using contact center where we're combining now in a pipeline, all of these different tools. You can see here, we're using Connect, Transcribe, Glue, Lex, and QuickSight. Here's another model where we're just doing basic texttract asynchronous API workflow. And then in SageMaker, because I don't want to ignore SageMaker, even though I said I'm not going to emphasize it today, here's a full sample architecture from the data, a new data element being detected in S3. It kicks off a retraining job that goes and kicks off a job in code pipeline that could go then to step functions, and it will go all the way to your hosted endpoint. By the way, that could also be kicked off by the model monitor here as well. Now, we do have one thing that's relatively new. We call it the the MLops framework. It is a template, really, for putting MLops into production. So I encourage you to, if you're a DevOps person, to start there, because it really covers absolutely everything in depth. Now, ML and other services, I only have a few more minutes here. I just want to cover, like I said, we've put machine learning in almost every service at AWS. All of the language that you see in this report, daily revenue, year-to-date revenue, was generated by an algorithm that's included within QuickSight, which is our product. That API is available. You could put this in your products as well. And the natural language query is available as well with a product we call Q. Getting models built with relational databases from Redshift is as simple as a SQL query. So you make that query, you can, number one, just call any service from AWS, like getting a sentiment score on some language, and you can do that with SQL, but you can also create complex models that go into production. So that works with Aurora as well, and even with our graph database, which is called Neptune. All right, last but not least here, look out for metrics is a new family of tools that we have that once again makes it easy for non-data scientists to detect anomalies in virtually any time series data set. All right, I covered a lot of material here, and I'm gonna pass it off to my colleague now, Miles Brown, but I do wanna just say one or two closing comments. And that is, this famous quote by George Box, all models are wrong, but some are useful. So it kind of brings it back to this concept that data writes code, you're going to be making predictions, and the predictions are the essential element of what goes into production. Some of the trends coming up this year include everything that I talked about here, MLOps, hybrid cloud, auto ML. So just ask yourself, can I write SQL? Yeah. Can I use the AWS console? Yeah. Do I know how to use a CLI or command window? And do you know enough JavaScript, Python to make a RESTful call? Then you already know enough to do high-level, highly accurate machine learning. So Miles, hand it off to you.
Sure. Chris, just before we move on, maybe people aren't clear on that term MLops and what that means. Maybe you can expand on that a bit.
Sure. So if you just Google, Agile software development lifecycle, you'll see that there's a lot of literature and really formalized process around how we get traditional programming languages like C, C++, Java, et cetera, from development into production. And generally we call this DevOps. So DevOps is a very different job from the programmers. You have to know a little bit about development, but a lot about infrastructure and how you put that in production. And there was a term added to DevOps called SecDevOps, where security became a real principal concern of DevOps in general. Now we're at MLOps, but it's really ML-SecDevOps. And what it really boils down to is, in addition to tracking the code, which we've done very well, right? We have GitHub repos, QA knows how to look at a spec, but when you introduce data as one of the principal authors of the code, it introduces nuances and completely new architectures for how you put that in production. Generally, we just call that MLOps, but you have to remember when you go into production, you can't ignore security, you can't ignore disaster recovery and backups and things like that. So it's really DevOps with machine learning.
Yeah, thank you. And that's one of the things I noticed was, in the early days when you had maybe one data scientist within a large organization, they were sort of on their own, doing their own thing, and DevOps might start to make its way into your processes, but then all the analytics and data science, that was all its own little thing. And now that's probably the biggest trend I'm seeing now is
it's huge.
They're
it speaks to the maturity.
Yeah, they're trying to operationalize the whole thing. And like you said, this isn't the purview of just a few, really highly specialized data scientists. It's sort of on every developer's radar these days.
Absolutely. Yeah. And it also says that this train has not left the station, right? You don't want to try to chase a train after it leaves the station. MLops is maturing, it's expanding. We need good, talented engineers in every single aspect of that software development lifecycle.
Yes, and there's a million surveys out there saying that this is an area where we need a lot of people.
Right, exactly.
And so it's definitely in demand. Let me just share my slides here. Desktop one, sure. I got just a couple slides about, well, first off, I want to thank Chris for doing this for us. It's rare to have somebody who's, so deeply technical, who's also a great presenter and can break these complex things down and make it, clear, I think, that this is within everybody's reach, to a certain degree. We at ExitCertified are an authorized training partner, have been since 2014 of AWS. We're also partnered with some other vendors. Typically, we mostly do vendor authorized training, but about 30 different vendors, but AWS is our biggest partner. And we've been doing virtual training since 2012. This isn't something new that we've just added in. Our regular classes, if you do want virtual training, they are based on Zoom like this, but it's not like a webinar style. We really encourage two-way audio and video, people asking questions as much like a regular class as possible. And you might see the logo here. ExitCertified is sort of the go-to-market training division of Tech Data. So Tech Data is, a very large distributor that you may have heard of. We have a lot of training on the AWS side. These are authorized AWS classes built by the vendor, delivered by AWS authorized instructors. We have a number on staff, like quite a large number. And we have these classes running, publicly. Some of the classes are a little more rare than others. They might only run every 3 or 4 weeks. There are classes, your sort of entry-level AWS classes that run every week. But if you have a group of people, we can put on a special event just for you. And okay, great. Oh, somebody's asking, I don't see a Q&A. Oh yeah, no, it's just the questions are going to be in the chat. So we encourage anybody who has questions, throw them in the chat. We're going to come back and ask Chris any leftover Q&A questions. So throw them in the chat if you have any. In the meantime, I just want to run down some of the major classes that sort of apply here. One of the things Chris said is that data is paramount to machine learning. And so if you want to learn about that whole data analytics stack in AWS, we have a 3-day class called the Big Data on AWS class. And it talks all about how we, starting from collecting the data with things like Kinesis, all the way back to, where are we going to store it long-term, like Redshift or maybe a data lake. There's also a 1-day data lake class. I didn't include it in this list, but that's a class we run fairly often as well. More specific to some of this ML stack, we have a 1-day class called Practical Data Science with Amazon SageMaker. As Chris mentioned, not everybody needs to be that deep, data scientist specialist. But if you are starting down the road and you want to build your own models with SageMaker, if you already have sort of that knowledge of data science and you just want to know about this specific AWS tool, we got that nice 1-day class. But if you want a broader, view of, hey, what is the job of the data scientist? How do I build and train those models? We do have this nice 4-day machine learning pipeline on AWS class. And that does serve pretty well to help you get ready for the machine learning specialty certification, if that's something you're going down that road. Now, typically, if you're going to be working in these things, you're probably already well-versed in a language like Python. I think Chris mentioned, I think you literally said it's the lingua franca of machine learning. And so if you're starting with you might be a Java developer, you might be, C# or something. If you just want a nice, gentle introduction to Python, we've got those kinds of classes. But we also have some classes where it says, well, if you know a little bit about Python, let's take you the rest of the way, because you're going to want to learn about pandas. And then, so we have some, comprehensive data science with Python. So these are not necessarily AWS classes. These are sort of language classes. And like I mentioned, we're partnered with a bunch of vendors. And then, for open source things, we have, various places that we gather. And we have, quite a roster of instructors that can help us with those things. And if you want to know more, you can go to exitcertified.com/AWS. Actually, let me throw that in the chat. You should be able to click through that, I think, in the chat. It should be a hyperlink. But you can poke around our website and see what's there. If you have a group of people, then, then you don't have to be so set in the 9 to 5 kind of classes. We have opportunities to do a half day over maybe more days. We have, total flexibility when you do a private class. But if you only have 1 or 2 people that you want to send on training, well, then we've got quite a robust public schedule for you. And right now we have a promo where you can get some cheaper training. It's our summer promo. You have to register by August 27th, and then you have to take the class, I think, by the end of September. And the way it works is basically, if it's a 1-day class, you get $100 off. If it's a 2-day class, you get $200, all the way up to $500 off a 5-day class. If you're doing learning subscriptions or on-demand or self-paced courses, there's 10% off. And so this is our current promo. We run these in the summer. The training business is a little bit cyclical. So the summer is usually a little lighter, a lot of people on vacation, but it is an opportunity for you, if you want, to get a good deal on training. And then also $500 off per day if you're doing private training. So those are all available. You can learn more at exitcertified.com/summer500. But this will all be, I think, the follow-up email that you'll get, telling you about the recording of the presentation, we'll have information about that promo as well. And I think that brings us to the Q&A. Let me see if we have any more questions for Chris. He's a great resource. This is a good time to get at him. He's also been kind enough to leave his, maybe Chris, if you want to throw your email address in the chat so people can.
Absolutely, happy to. I'll also point out, I'm going to put in the chat right now a link to my deck. So that deck is accessible to everybody. And it includes some of the demo code, so you can play with that. But yeah, any questions, definitely eager to hear them.
Yeah, we really appreciate that, because some of those architectural diagrams,
they come in handy.
You might want to take a closer look at those. Yeah,
exactly.
Oh, sorry, and your email address? Oh, you're
and then I have a question for you, Miles. I mean, if you don't mind. So do your courses, oh wait, we have some coming in from our folks.
Oh no, it's just Matthew putting the promo.
Oh, I see. I see. If I wanted to make Vision AI that identifies birds that fly over my house off the top of your head, how much effort do you think that would take? Yeah, that's a great question to ask. Well, first of all, the courses that Miles just outlined will give you that introduction to Python and the IDE and the access to where you're going to store those pictures of those birds on AWS. And that's the starting point, right? That's we used to call, when you get in a taxi and you have to pay something just to sit in the cab, that was the unfare, right? Like, so that's what you've got to get through before you can start identifying those birds. But then now, once you've got your data set, or maybe you're assuming that you're going to have a live camera Cameras take individual pictures. They do it at a rate of 30 or 60 frames per second. For machine learning, what I've generally seen is like 5 to 6 images per second. And there's a way to run that through a pipeline at AWS to call recognition. So a low code way to do this, but like I said, you're going to need a Jupyter notebook and Python knowledge, is to tie all that architecture together so that it calls recognition every time one of those new frames hits S3. It calls a Lambda that calls recognition, and it identifies the bird.
So you're saying that recognition already has a library of what birds are what? Probably labeled?
No, you have to get that data. Now, there's a lot of ways to scrape that off of Google Images, or preferably, you would have photographs that you took yourself with that camera that you were using to identify. It's always better to use your own data set, right? Take those pictures, use custom labels in recognition, and you can build a model.
Okay.
You want to take the next one, Miles?
Yeah, there was another question here. At what point does the code become ML? Because it's possible to hard code an algorithm that acts like ML. If you don't mind, I'll just do this. That's really where scikit-learn comes in, right? Scikit-learn is sometimes called shallow learning, but that's not right. A better word is classic machine learning, where you're basically just not using deep learning. And if you go through scikit-learn, you'll find that most of it is based on, statistics. It's a lot of statistics. So I do not discount scikit-learn or classical machine learning, right? And where the actual line is, it's a big gray space. So deep learning is always going to be ML. That's just a given, right? But when you're in scikit-learn, you're doing classification with statistical methods. Yeah, it can be very gray area. Is it really machine learning, or is it just a statistical prediction? And then I see the other question here, follow up on the bird identification. I was also wondering if AWS has a pre-built recognition system. Well, yeah, that is recognition with a K, not a C. And it does identify a lot of objects, but it's not going to identify species of bird where you live. That requires a custom model, or what we often call bespoke model. Is ML specific to the differentiation of sensory input? I meant for differentiating birds from things like planes or flies. Well, if you don't mind, I'd also mention, it's machine learning and object identification is so sophisticated now that if you can label it, you can identify it. It's almost that simple at this point. Individual dog species, if you have the correct label, for example, that's the classic example that we use, different dog species. Load them up into either FastAI. FastAI has a really good framework for that. MXNet has something called AutoGluon, which will create a custom species detection model for those birds. So yeah, there's many roads to Rome here. It's really just a question of what degree of accuracy are you going to be satisfied with. But even out of the box, recognition, if you give it a bunch of images and you say, hey, which ones are birds versus which ones are airplanes, it'll do a pretty good job.
That'll do it with out of the box. Yeah. That's an API call.
It might not know. It might not know too many species of birds.
It probably knows some. It probably knows a robin versus a crow.
Yeah. But yeah, if you want to really get into it, you're probably going to have to go and custom label and feed it a bunch of images of a specific species. Right.
Yeah. I have an ongoing battle with the crows in my neighborhood, so it's a little bit of a sore point.
Nice. Okay. Well, it sounds like Christopher's well on his way to having a good starting job with that's the kind of project that you can really delve into and learn a lot on your own.
Absolutely. It's a great starter project. Yeah.
All right. We got a couple more minutes. If there's more questions, you can throw them in there.
And Miles, the question I was going to ask you is what kind of skills do folks usually have coming into your courses? And are there requirements really for that matter?
Yeah, so typically for something like that 4-day machine learning pipeline, there is an assumption that you've used AWS before. And so if you're brand new, then you should probably take the 1-day Tech Essentials class, where we sort of cover, hey, what is cloud? What is AWS? What are the basic services that everybody uses? And get some hands-on, with a few labs. And so that's like sort of like an 8-hour day class. If you've used AWS at all, you've logged into the management console and maybe launched an EC2 instance or something, then you can safely skip that class. But that's usually the grounding for the machine learning class. But something like the big data class, because there is this expectation that we're touching on a lot of services that build on the basic services, you probably have sort of what we would call an associate level knowledge. So the next level up from the Tech Essentials would be the sort of 3-day classes, like, we have 3 of them, one for SysOps, sort of administrators, one for architects, one for developers. And so that'll get you the, hey, here's the 25 services that most people use in AWS, and get hands-on with those. So you get sort of 3 days under your belt. So if you've taken whether you take the architect or the SysOps or the developer class, then you'll be ready to go into that big data class where we talk about, some of the things you mentioned, Redshift and Glue and Kinesis, EMR, some of those data wrangling kind of techniques. But it sort of depends. We actually have on our website kind of a path. Actually, let me just show it to you, just so people can see it. Yes, everything's always in the way when I do this. Okay, so here's our website, and let me just go to the resources section. Okay, I'm going to get all these things out of the way. Yeah, I'm going to go to the resources section, and we have what we call learning paths. And if I go find the one specifically for AWS, you can also get there from the AWS page, but this is usually my fastest way in. Let me find the learning path, AWS. Yeah, here we go. So this is a 2-page PDF that we've sort of built out. And you'll see that most of the tracks start with the Tech Essentials 1 day, then go to either the architecting or the developer or the SysOps. And those would get you ready for your first level of sort of associate level certifications, if you're going the certification route. And then there's some professional level certifications. And then awesome. On the second page is where you see, hey, here's more of the data analytics side, where you might take the architect or the SysOps, and then the big data class. You might take the 1-day data lake class. If you're into machine learning, like I said, the 1-day Tech Essentials, the 4-day machine learning pipeline, and that'll pretty much get you ready. You probably have to do a little self-study, but get you ready for that machine learning specialty. And it goes on. We have some classes specifically on serverless solutions, Lambda and API Gateway. We have security classes. So we've got this sort of 2-page kind of sort of learning and certification path. And these are all AWS built. They maintain them. That's the big difference with getting authorized training from an AWS partner is, sometimes you go to one of these gray market things and somebody built a class, but 2 years later, the cloud is such a moving target that, you need the power of that vendor updating those classes. We have these updated classes every 2 weeks, pretty much. Something's changed and we need to update them. So that's sort of.
I'll also mention that 80% of the employers that you might want to work with after you take this course or customers, their data's on AWS.
Oh yeah, for sure.
So, data writes the code. If you're going to get into machine learning, you better go where the data is.
Yeah. All right. Let's see if we have any more questions. We get some thanks for great information. All right, we'll just stick around for another minute or two, see if any more questions come in. Again, thank you very much, Chris. Really appreciate your help with this. And
my pleasure entirely.
You've got his email. You've got our website.
My social media there. I do a lot on YouTube. A lot. I run the New York City Deep Learning Meetup, and we get into a lot of details, a lot of data science, and it's there's some good stuff up there. So if you were going to check out one thing there, it would definitely be the YouTube channel.
Are those meetups, are you meeting up virtually these days?
Yeah, and I don't like it.
Yeah.
I can't wait to get back into the loft. I love human interaction. Yeah.
Oh, you guys were hosting those at the AWS?
At the New York City AWS Loft in Soho. Yeah,
Nice.
on West Broadway. You can fit like 250 people in there. It's fantastic.
Yeah. Yeah, there's a few cities that have those. And that certainly makes it easier. Yeah.
London, Tokyo. And I think there's one more question here.
Okay.
Someone prompted us, but
I think he's typing it.
Oh, okay. Yeah. Cool. No,
yeah, I went to the San Francisco loft.
If I want to build out an ML API that integrates about 10,000 transactions a month, what would that cost be? Typically around 5 KB per transaction. Well, total cost management is a priority. It's one of the well-architected principles at AWS. And when you say it's 5K per transaction, it's really, we need to get into, there's more questions than answers here. The short story is there's an optimization path for almost any type of inference. I mentioned that we have custom hardware for inference. We also have an IoT suite that includes a lot of cost optimization tools to get that data, if it's coming from an IoT device at 5K, to the model. So we have a number of architectures that are in the machine learning blog on AWS that talk about cost optimization. But yeah, I mean, I think the number of questions here around, what this is actually going to cost can be very difficult to answer. Just one little nuance, for example, it doesn't cost a penny to put data in S3, but when a user reads it, then, we charge for the read, not the write. So, that's just sort of one nuance here. Is this data already in the cloud? Is it, coming from an IoT device? Is it a web app, a mobile app? There's just way too many questions to in front of that. But we also go out of our way to keep costs as low as possible.
Yeah, and I guess it kind of depends which ML API you're using too.
Right, an AI service versus a bespoke model.
Yeah.
Versus you can call models from Lambda. You can put containerized models in Lambda, call them from Lambda. We have pre-built algorithms in SageMaker, and they can go into production as a SageMaker endpoint. And then that SageMaker endpoint can host any number of individual models. So that's called multi-model hosting. So it gets nuanced very quickly. And that's where you need good training.
That's right. All right. Thanks. Well, thanks for that. Yeah. All right. It looks like we're pretty much at time. So I think we're going to shut things down. But once again, thank you very much. And everybody look forward to the email coming probably, I think we said, Michelle, was it end of the week? Maybe we were thinking probably the email with the recording.
Yeah, we'll get that out at the end of the week.
All right.